who I was and where in that first bit. I was actually part of one of the teams that visited Toronto with David Edinburgh in 1960. And then later that year, joined the student development program on Brown and led the team developing the first 1902-3 executive. This led on to the other executive test software, so we grew to what we call a software division, rather grandiosely, of 100 people. And then later I was in charge of combining Manchester and Stevenage product software, which was Charlie, and was a program manager in 1993, and I had a certain amount of involvement in anything later, so I was involved in the range in some form or other quite a long time. Next. The executive was at the heart of the 1900 series. It activated and controlled other elements. It and the hardware combined to provide range compatibility in a way across many different hardware implementations and different operating systems. In fact, in a way never done before, nor actually quite that long since, I believe. This both enabled different hardware-software trade-offs to enable different systems, and meant that a program written to run on one operating system at the lower end of the range would run completely unchanged on a totally different operating system at the other end. And with some exceptions, compatibility worked the other way around. Executive was not just one program. There were in fact numerous types of executive over the life of the range. And these executives were largely different software implementations with different operating system characteristics. I recall a dozen such at Stevenage alone prior to 2003, and the total must probably double that. And these executives range from the very small through to what the powerful operating systems in their own right. Executive controls the multi-programming and the peripherals, handling all the real-time aspects. And Charlie's explained the parameters already. So executive can start program, assign peripherals to the program as requested, accept a program peripheral command, translate the program's logical number to a physical one, give the appropriate commands for that particular peripheral's hardware to start it running, and that would happen usually in parallel with the program continuing. When the program couldn't continue, so for example, needed data from transfer, executive would suspend it and started our priority one, switching back to transfer was successfully completed. Executive looked after error recovery incidentally where possible. Executive also provided the file systems on most disk and magnetic data systems. Like in most versions, Executive was a freestanding operating system in its own right, able to control all of the system, hardware and programs by itself. In the upper middle of the range, it was supplemented by George 1 and George 2, and all the interactive systems, Minimod and Maximod, which ran under programs under it. George 1 provided job control of program sequencing, and George 2 added I/O spooling. At the top of the range, George 3 provided the operating system features, including the file store, and George 3 executives were quite unlike those in the rest of the range. They were slaves controlling the peripherals for hardware time-sensitive aspects of multi-programming. Lower down the range, there was no room for a separate George, and indeed eventually such things as job control and spooling were built into some of the executives. Thus, paradoxically, the executives for the larger machines were much smaller and less visible to users than they were on many systems at the lower end of the range. In fact, executive was thus the operating system for many 1900s, including smaller systems. Probably numerically, but indeed numerically, far more 1900s ran just under an executive than under a George. Also, even on some larger systems, users of the simple hardware might prefer to work with freestanding executive plus George 2 rather than George 3, or transaction processing with a transaction processing monitor running on top of executive. George 3, of course, provided far more sophisticated facilities and was essential for any large user population, particularly for doing mob. And counting all the end users of large George systems, probably wouldn't like to say whether there were more end users of George systems or more end users of freestanding executives, not important. But executive did have this independent role as well as be supplementing the operating systems. Executive's role in providing compatibility was key, this has been said, and it provided a common application interface across the operating systems, except on George 3 systems where this was done by a combination of George 3 and executive. It insulated the other software, including George 3, from the quirks of specific hardware implementations, whether of processors or peripherals. Now, this was unlike the IBM 360, where the hardware autocode was the same, interface was the same across the range, but the interfaces of different operating systems varied. On 1900, the hardware, other than the basic instruction sets, could be different,
but the interface to software above executive was kept the same, and hence a program running on one system would run without any change on another. And this was unlike other ranges, where changes, for example, to the peripheral driving instruction were needed to go from one regime to another. In fact, executive could be considered to be effectively part of the hardware, And it's noteworthy that it was managed as such, with the executive team being part of the hardware development groups rather than the software one. This meant that the hardware and software designers could work together to make trade-offs differently at different points of the range. And these trade-offs would change as cost parameters changed and as technology advanced. And incidentally, we even used the hardware change control procedures for changes to executive slide. The origin of the 1900s executives, the FV6000 one developed by Ian Sharp's team in Toronto. I recall that when I went on that trip as part of New General Steam. As a key feature. This version was small, I think it was only 1,024 words, and its purpose was to provide a protected multi-programming environment for controller peripherals. However, many of the key features, such as controller data and limits and sub-programming, are present in this clever piece of software. The peripheral set was at this stage very limited, with relatively simple drivers. This was developed in Manchester to be the original executive of the 1904-5, but before that was completed, key events occurred which gave the executive an even more fundamental role. Previous speakers have explained how the idea of the 1900 range came about. The need to provide a replacement to the defunct Poplar in very short order, as I recall it, required a machine on which the existing 1904 software could run with really virtually no change. It really was essential. And to keep the hardware costs down, several of the more complex functions were to be implemented in software, and it was decided to incorporate those into an executive with a smaller machine with an appropriate entry mechanism similar to the extra codes used for driving peripherals. Those were called extra codes. And when I say more complex functions, I mean such as multiplication and division. Hardware was more expensive in those days. 20 points or so later. I wrote the extra codes myself, and I recall poring over the 1904 logic diagrams to achieve the same results. Eventually, these software routines emulated exactly the 1904 hardware, even in out-of-range area conditions. And I remember the inner loop of my division routine with its misuse of carry is the most diabolical 4 lines of code I've ever written. This machine in 1902-3 was not required to provide multi-programming, hence some simplifications, and in other ways the hardware was very cheap and done more than an executive. However, an identical application interface for executive for peripherals was implemented on both 1902 and 1904-5, of which more anon. The first 1904 and 02 executives were produced in parallel with the hardware and were demonstrated at the BE in October '64. Developing the 1902 version done from scratch and debugging it in 2 months from first sight of its hardware was a frenetic activity. We were very proud of the use of real, not just a demo system, even with a tape library for program loading if we had it in the last minute. Thus, the 1902 and 04 executives were compatible not in hardware, but the interface for the combined hardware and executive component presented to the applications and higher-level software. I just re-emphasize what's been said many times before. This was a unique and key aspect of the 1900 compatibility. The key factor in retaining and subsequently maintaining this compatibility was the 1900 compatibility committee. The committee formed out of some ad hoc meetings in the early summer of '64. Bruce Patterson was in charge of software planning as chairman, Tony Hetherington representing the software interests, John Bell, John Thompson and Mike Davis were the first representatives from Manchester, and Colin Taylor and I, those from Stevenage. I'm very glad to see several of those here today. Others, of course, played key roles, maybe then later, and my apologies to those I haven't mentioned. The body formed itself spontaneously. It wasn't called into being by some management action. And of course, the commitment of its members came from the heart without there being any feeling of imposition or unnecessary constraint on technical design as a result. In fact, our management saw what was going on and were very happy to let it happen, wisely not interfering in any heavy-handed way, and in due course gave us a formal point to report into. A key early success of this body was a decision to change the peripheral driving instructions from those of the FV6000, the ones from executive, application executive, to a much more flexible and extensible set under a new Perry instruction. And I think much credit goes to the Manchester team and the software writers under Teddy Hetherington for agreeing to this. It meant extra work at this point from there. And in many other circuits, it is not invented here. Syndrome has prevented it happening. The Compatibility Committee continued from this point for the life of the 1900 series, and the importance of the compatibility required the same interfaces provided with George Street 2, so the then chief programmer of that team, Henry Goodman, who I see is here also today, joined it too. George 3 provided, of course, other facilities, as I'm sure George Goldman will describe it, but it always supported these primary executive interfaces as well. The Compatibility Committee grew and developed subgroups, but it was a very effective mechanism for those involved, albeit it had some downsides and some frustration for those who were outside its ambit. Overall, it was an extraordinary success, and the compatibility achieved was really very good. I recall that when the 1A and the 1901A and 1902A systems were introduced, Peter Hunt set up a long program of tests to prove that these systems really work compatible with their predecessors. This program was actually abandoned after a few weeks as unnecessary. A remarkable achievement. Together. As the range developed, new features were added which could only economically be implemented on larger systems. We found one or two tricks for dealing with this, like arranging that executive would give a zero response to any extra code it didn't understand, so we could invent new uses for unassigned codes. And the software just had to check for zero to see if the response was a real response or just meant not available in the system. And so again, we didn't have to implement the feature all across the range at once. There were a couple of other major changes to established interfaces, as well as the very early paragraphs, and I shan't go into these, not time today. I've actually included this and a few other points in a rather an extended version of my paper. But by and large, full compatibility was maintained. So this compatibility was achieved by this cooperative effort between the teams at Manchester and Stevenage and the George team, all under separate management in different divisions. The cooperation between hardware and software designers in creating what are in effect joint designs, coupled with this democratic cooperation between the software team and the Compatibility Committee, form a remarkable episode in the history of the computer industry. There was an interesting blend of rivalry and cooperation between the executive teams at Manchester and Stevenage. Mike Forrest has already referred to the good results of having friendly enemies, as it were, cooperating, people who cooperate nevertheless who are rivals with. I can give a lot of examples of this. There's not time today, and I've documented some in this extended version of my paper. One aspect was that when a new peripheral was added to the range, we could have different ideas on precisely how it would be controlled. But whichever the team who first was going to implement the peripheral would decide how they wanted to do it, bring that design to the Compatibility Committee. The other team could comment and raise any objection, but then they would accept the interface, whatever they thought of it. When they came to implement the peripheral driver, if that peripheral came to their system, they would do it compatibly. Discs, I recall, were originally Stevenage, and drums and multi-card file originally Manchester. The rivalry was in fact very constructive, as was the equivalent between the hardware teams. The teams themselves were fairly democratic and worked well with complementary skills. We did produce some remarkably bug-free software for most of the time. Early on, all Stevenage executives had to be generated onto cards or paper tape individually for each site. We had no patching mechanism. So to repair that, we'd have to do a complete reissue. We got away without disaster on this for a really surprisingly good time. The development of George 3 on 1967 was a big job, and like most large operating systems, it took some time to achieve maturity. As has been said before, the fact that even the largest machines could run under their freestanding executive provided some shelter for this, as customers could use their machines for commercial work while trying out early versions of George 3. Incidentally, there was initially a firewall between George 3 and its executive, so George couldn't corrupt executive. Once it was complete and reliable, that was removed and replaced by a more intimate interface to improve performance in about 1970. Much could be said about the many different variants of executives that developed as the range was extended, but there's obviously time for only a few points today. I've documented a bit more. One point is that the performance and size of the executives were important considerations. Obviously, the performance overheads for driving peripherals and other time-critical activities had to be kept low. And I recall counting instructions to the region of 10, 50 or so. We wrote quite tight code. But as important, the store occupancy, even more on the small systems, where executive could take a significant percentage of the available store. Executive sizing was an art form, including leaving space for enhancements so as not to take more store away from existing applications. Note that all early executives were held in main store or core residence. Also, another aspect was that the specific executive of a particular machine was tailored to its configuration to include just the peripheral drivers and tables that that configuration needed. It was generated from the master for that executive type. I was earlier talking about different types of executives, I was talking about different types. With the arrival of DIST, it became possible to overlay executive. Single and multi-program overlaid executive were due course developed to Stevenage and multi-program one at Manchester, and this allowed other features to be added inside executives such as jump control and spooling. So we developed in 67, 68 complete new executives at both Stevenage and Manchester. At Stevenage, we were rather ambitious and have been very successful recently, so went overboard for a very sophisticated method of store allocation in the form of pseudo-paging in our multi-programming overlaid executive. Eventually, this paid off in 2003. It made this possible, but it caused us an awful lot of misery on the way. Whereas in contrast, and this is part of the team rivalries and learning from each other, at Manchester there have been some recent difficulties on the executives, and Charlie Horton, who just taken over the team, insisted on using safe programming techniques. And as a result, produced an executive which was a lot more reliable to start with. George 1S, to complete the slide, was the single program overlaid executive job control facilities, including the equivalent to George 1, incorporated inside it. And we also extended the multi-programming overlaid executive to incorporate George 1 two features, including spooling, using our dynamic overlay. Next. No. Well, that's fine. The next big development of Stevenage was the 2903, which was developed in parallel with the early 2900 systems, as we described before. It was conceived as a 1A replacement, but had an 8-bit microprocessor, and Brian Proctor will explain more about this. That allowed us to add other facilities like direct data exchange, entry, and transaction processing. And a new generating system was developed to support the microcode. That technology was then used to provide the basis for direct machine emulation systems on the 2900s by the team under Colin Taylor. These enabled 2900s to be run as 1900 systems, including running the 1900 operating system executives. I'm sorry, operating systems, that is George and its executives. And were of great importance for ICL and its customers, allowing customers to continue with their live workloads while developing 2900 equivalents, and while the ambitious BMB operating system was brought to maturity. So that the 1900-2903 philosophy of executive microcode served to provide ICL with another vital support for its revenue stream in the mid-70s. The last system, the last system in the series was the ME29 developed in 78-79, which was given a new operating system, TME, the transaction processing environment, which had the facilities of previous systems, but together with additional communication and transaction processing. And again, it supported the 1900 compatible interface. So through 2 decades, the 1900 series was developed with unique compatibility supported by many executive operating systems, enabling a smooth transition of customer applications and other ICL software. Both as new machines, new technology developed, and as customers outgrew their existing systems, traded up the range of satellite systems, or added satellite systems. It was achieved by teams where hardware and software expertise was for the critical period under common management, with cooperation between divisions where rivals were healthy and not destructive. Those with long memories may recall the title of the TV series that followed on from That Was the Week That Was. And I remember we had pinned up on the wall at Stevenage, executive, not so much a program, more a way of life. So it was.
technologies, innovation and evolution.
So I'm going to talk about primarily about the hardware of the systems. I'd like to try and do a quick tour through the 1900 range in chronological order. Virgilio said that he wanted some visual material, and since I always do exactly what Virgilio tells me, as is well known, I've in fact got a number of slides of various bits of machine technology and so on, which I'll try and intersperse into the talk at the appropriate moments. I've got quite a lot of material. And Arthur will prompt me if I'm running late, so I'll go through it fairly quickly. And in particular, when we get to the slides, I should just flip through those, just so as those of you who can remember the machines just are hopefully reminded of them. Lots of this material, as I think has been said earlier, when we look for records of some of these things, we didn't find the records. So a lot of this material is actually reconstructed from the memories of the people who put it together, and I think we will be very grateful for adding your memories to that. So if you have things to contribute and say that's wrong, it should have been there or there, please tell us afterwards to improve the state of knowledge. I should say in my credentials that, following on from Michael's remarks, I was in fact one of the team that came from EMI with Norman Brown. I worked at Stevenage on the smaller 1900s until Stevenage closed, and I went to Manchester where I've been ever since. So I haven't even got a slight Manchester accent. So, talk about process technology. I want to try and define the use of the word technology fairly broadly. Some points have already been made that one of the interesting things, one of the interesting achievements associated with the 1900 range, and indeed what much that ICT and ICL have done, is the achievement which was produced by really quite small teams of people against the competition, particularly IBM, which was, as already been said, spending more on R&D than ICT actually had in terms of its total revenue. So I wish to just remind ourselves that when we talk about technology, we're not just talking about the things we see over there, the hardware bits, but we're talking about the processes that went on behind those, the design processes to enable the design engineers to actually design the machine in the first place, and talking about the manufacturing processes that allow the factories to turn that into I'm going to use the roadmap which Virgilio put up, and as Virgilio pointed out, it's a fairly complicated roadmap. Basically, I've tried to colour in the different series of machines so you can follow the lines of each type of machine, each model number of machine. Across the top of the roadmap, designated the various different series of machines that occurred. And I shall go through the different series of machines, so I shall keep referring back to this so that you've got a little bit of orientation about where we are. So first, we're starting off with what I call here the original machines, the ones that were announced in the first wave of announcements and which were exhibited in the first year of the first exhibition of Nuclear and the second exhibition of the 91 came. So the machines in that bunch comprise the original ones, which are 1902, 3, 1904, 5. In fact, 1909, which is not shown on that slide, because if I'd drawn it, it would have exactly overlaid that would be even more confusing. And then a little later, the 1901 and the 1967. So for that group of machines, technology. Now, as has been said earlier, the important thing here was that we were trying to expand from the original FD6000, which was a single-point design, to a position where we could expand that to cover a range of machines. But the important thing was time to market. We wanted to get in there to get that market slot before IBM started shipping 360s. So time to market is very important. Now, choosing the technology, as has been said earlier, the choice was very much to go for a proven technology, one that was well understood. halted. So the technology was the technology of 700 series packages. There's 3 examples over there. I've got some slides to show you in just a moment. The capture, the design aids, capture of the logic is all done side by hand. Those things were connected together by backplane wiring, which used a form of what's called POCOM wiring. I'll show you a picture of that, not very good pictures, but some pictures of that. Wiring lists for those were actually generated by computer from manual inputs. And then there was a bit of automation in the factory to actually help the production of those backplanes. There was a jig made such that an operator would sit on one side and the machine would actually tell the operator to connect this to this, and the operator would make that connection with a wire that was pre-cut to the right length. And sitting on the other side of the machine, another operator would insert 2 test cards, which would then test that the link had been made between the right 2 places. There's a level of kind of semi-automatic operation in the factory. So hopefully my multimedia technology will now work. And okay, here we've got the 700 series packages. That is the one you can see over there. This is the, I suppose, the archetypal 700 series package of 701, which was just 6 gates. The technology was essentially similar to the technology we used in FB6000, it was just slightly emphasized. My colleagues in circuit design tell me that it was the transistors were changed from, the sets of the transistors were changed from germanium transistors to silicon transistors, which were then becoming more refined. So that was the basic package, and there were variants of that. This is a slightly more complicated one, with 12 gates on it. And again, a more complicated one still, which actually are cheesier. This actually comes from the next range of machines, but you can see that there was some development during the period. Basically, the technology was exactly the same. It was fairly simple printed circuit boards, but they did become denser as time went by. Not a good picture, I'm afraid. I took this under rather difficult circumstances. This is a machine, this is actually a 1905E, and this bit of the machine is actually screwed to a corridor in the University of Manchester. It's the only one I can find. But I think you can just about see on here what looks like a rat's nest of wiring. In fact, these wires cut to length, different coloured wires, different lengths. The operator selects the wire of the right length, plugs it in the backplane. That's how the wiring is made. A very quick way of wiring, and with the constant check machine, a very active way of wiring. Next. Okay, so that's the technology. And now what do we make out of that? Then the first series of machines, I've just lumped together, I've lumped in the 1901 and 1967. So we started off with the 1904, which is essentially the FB6000. The left-hand side of the slide is essentially the commercial machines. The right-hand side is essentially the scientific machines. Scientific machines, by and large, the larger machines were all an odd-numbered version of the commercial machine. And in all cases, they were made by adding an extra piece of logic on to provide floating point arithmetic. On top of the machine, it's called floating point unit. On the bottom end, it was called extended mathematical unit. That's right, in 1902 and 3. And in that case, rather than calling them different numbered machines, they just had this feature. So those are the scientific machines derived out of the commercial machines. To go from the FB6000, we went upwards into the 1906, which is essentially a new design, a new implementation of the FB6000 architecture. Had more registers, more logic inside it, capable of operating more quickly, taking less internal instructions to actually perform a 1900 instruction, therefore went quicker. And there were 2 versions of that actually, one of which had a quicker store on it and gave a 30% increase in performance. So that was going upwards. Going downwards from the 1904, as Brian Millis has always said, we did some simplifications. We left out some of the more expensive instructions, things like move instructions and multiply division. Those are provided by the extra codes that Brian spoke about, so at the program level it was still all compatible. And that was produced in 1903. 1902 was exactly the same as 1903, but fitted with a slower store, 6 microsecond store, which is cheaper. And then subsequently, a year later, to get to 1901, we did get a further simplification on it. And in particular, we went to a much reduced size in terms of data routes. The machine had a kind of serial parallel function out of it. It actually processed one byte at a time. If it had to process the whole word, four goes of doing it. So those are those machines, and again with a bit of luck, I'm uncertain about this one. I'm not sure it's a 4.5 or a 6.7, but it's one or other of those. If anybody recognises it, perhaps they can tell me. This is, here's another one. That's probably a 4, I guess. In fact, it's got 3 ways in it. This is a 1902-3 with the console typewriter in the foreground. And this is a 1901. The 1901 installation, actually taken in a room. This is a mock-up in Stevenage, the south side of Stevenage, which has been unoccupied. It's been used for photographs just prior to it being exhibited during the period of the business machines exhibition. Also see some peripherals on there, and I'll show you some more peripherals in a moment. So, coming on to peripherals, it's not really my purpose to talk about peripherals, but Michael's already mentioned at the beginning. Clearly, they're a very important part of to offer a wide range. We've had to have a comprehensive range of peripherals. Lots already been said about stand-in face, so I won't dwell on that. But the common peripheral range, and Michael already, I think, mentioned the 18 peripherals that were there originally for the first announcement, and those subsequently added to. These types of peripherals were available from the beginning. Rather interestingly, on that list, no extendable disk file, no extendable disk store. Although I'll show you a picture, which I took from a brochure, a book rather, that was produced for the 1964 Business Efficiency Exhibition, which shows a picture of an extendable disk file, disk drive. And I would be very grateful if somebody can throw some light on it. So just to have a quick whiz through those peripherals to remind people what they look like. Sorry, I'm out of step with my multimedia presentation, of course. These were some installations of the machine. So this is I think a 1905. This possibly is a 1905 at Southampton University. Next. This is a large 6.7 in
Ministry of Social Security.
That's it, that was it, yes, that's the one. Right, those are the other configurations. So now we're going to the peripherals, please. Anyone? Card reader. Yes? 1920 card punch. What's this one? I'm not sure what that is. The other card. It's a card reading thing, is it? Right. Famous line printer that went on for years and years. Wonderful line printer, 1933. 1916 paper tape. Now here's another one. On the back of this photograph, it says 1916. Does anybody recognise that?
Yeah.
It's right, is it? Wonderful. I've never seen one of those. I was really baffled when I saw that. Okay, next please. 1971 tape system. 2501 cassette tape system on 1901 had continuous loop of tape. 4 cassettes plugged in the top there, continuous loop of tape in them. A sort of pseudo random access device. I think Data Products, fixed disk store. They have one of these at the University of Manchester. There it is. There's one of the discs that spun very fast, as in the Bryant, which people were very worried it was going to shatter as it went round. And you can see the size of it. And this thing here is the head actuator. If you looked inside your PC, you'll know there's a little bit smaller in the This is the Bryant. Now this one was on in this original book, which was produced for the first Olympia exhibition, that described the exchange of goods. There are 2 or 3 pages in the book that describe track layouts and all sorts of things about this. I've never seen that. I don't think it ever went into production.
Yeah,
Did it? It was the other one.
we never got
Right.
one.
Interesting. MCF? Sure, that's what that is. And our delightful model without exhibit, the universal document transport. You can see from the accoutrements lady, very much in 1960s photograph.
I think that's one of the photographs in which the top and the bottom half of the lady are actually different people.
So, we move on. That was the original series of 1900s. The peripherals were rather wider than that, and I haven't got any more peripheral photographs. So we now move on to the EF series. A couple of machines in the middle there. Used essentially the same technology. As Charlie said, these are machines which we use, in which various extensions of the architecture were introduced. They had hardware accumulators. These were the machines, I think, where dual processing was first introduced.
The Fs is the 4F and the 6F, I think.
No, 6, 7.
The 6s were dual processor versions of the 4.5. These are, yes, sorry, my nomenclature is not very clear, but I think the duals were dual processor versions of the 4.5. You added another processor, and that made it the 6. So a number of architectural things. Interesting in that actually this thing was a little mini sub-range on its own right. There are a whole range of machines here because you get quite a big performance difference by taking this option. Another quite big performance difference by taking this option. So by combining these things, you had quite a few machines there, all built out of the same basic core design. Nice benefits. If good customer growth paths, you can take the smaller one and then enhance it in the field. And of course, it very much optimised the development and manufacturing investment. So an important series of machines. No. Don't think I've got any focus. Sorry, one more. Probably has to. Quickly turning to maybe a slightly abstruse topic, which talk about the control, the way in which machines were controlled internally. Control is an expensive thing in machines, especially in these early machines. It used up a very great deal of logic to actually provide the control system. And one of the quite interesting things to me, anyway, looking back on them, is the different ways in which this is handled. The original FP6000 used what we would call nowadays a hardwired control system. That's to say the control was actually implemented using the basic logic families. Now, these systems were okay, but they tend to get rather complicated, and they tended to use up a fairly large machine, quite a significant portion of the total machine logic. So, but they were used on the 1904 because it was a derivative from the FP6000, and the 5, of course, which was the same thing, the floating point, and the 9, which is the same. We also used them for the 190123, essentially because there was no alternative technology which would give us the same results at the right cost. The actual way in which it was done was a bit different, but the principle was fairly similar. For 1906-7, which was quite a bit more elaborate machine internally, the decision was taken to actually use to take the control, and instead of spreading it out onto the machine, to bring it all together into a store, organised store, a regular store. And so the 1967 had a microprogram store. And in fact, the 1904-5, the EF series, which we were just discussing, also used microprogram store. Used it a bit differently, actually. Actually, allowed it to be only half width, but essentially was much same technology. There's a store, a bit of the store over there. And actually, I think, if I remember correctly, I have a couple of. Yes, this is the top of the 1904 gate. And sitting on top there, you can see just on top of the diagram, that store, which is the same one, same as the one you see over there. And in fact, underneath it was this blank metal plate, actually that covers another one of those. Each of those things was 512 words. Two of those in 1904, each 48 bits wide. And this stuff underneath is the logic which actually then drove that store. In fact, that rather more complicated board I showed you at the beginning of the presentation, the most complex of the 700 series boards, was actually one of these that sat under that store, driving the store. Probably accounts for the fact it's missing in there. Right. Well, sorry, the other point I must say over here is that it's if I go on from that, so that was the store, that store logic used in the 1904 series. When we moved on to the A series, we were now using integrated circuits, and actually the practicality of making a store like that, when you did that, you got to the cost came out all wrong. It was actually cheaper than integrated circuits. However, at this time, integrated circuits had no storage capability, no large-scale storage capability. They just didn't exist in the integrated circuits that were available there. So these machines all went back to this hardwired form of control logic. And it wasn't until we got on to 2903 and then ME29 that integrated circuits had progressed to the point where we could actually build regular stores. And now with one big advantage, these stores, whereas that one was a fixed store that the pattern was put into at the time it was manufactured, these were actually loadable stores. And what we did there was to allow us the capability to blur the distinction between what was executive and what was in the basic control of the machine. So we could use that in 2903 and ME29 to execute quite complex operations very quickly. So things like the direct data entry capability in 2903 would not have been possible had it not been for that writable store. Now we've gone to the A series. Set of machines introduced around 68, spreading out some time now. Full set across the complete range. And these were architecturally, they used all the architecture which is now robust and which had been proven in the earlier machines. But what happened, the big thing that happened here was that these machines, whereas the earlier machines had used technology very conservatively because they wished to get to market quickly, these machines were very aggressive in their technology. They used leading edge technology. And this actually gave them a key competitive advantage. It helped them to move them up against the competitive machines and helped to prolong their life. So these are very important machines. In many ways, these are very much the central machines of the 1900 range, like the flower of the 1900 range, to flowery language. So, looking at that integrated circuit technology, it was a complete new technology, using integrated circuits because of the speed and size of it, rethinking the entire packaging. So the packaging, we needed new automation tools to go with it, was going to design it. Manufacturing had to make a huge investment in manufacturing capability in order to manufacture the much more complex printed circuit boards, and in particular the things like that 1906A Platter, which is now destroyed. So there was an enormous step up in manufacturing capability. There were two different approaches used. Well, let me jump on. There were two different circuit families used. The 1901A to 1904A used TTL technology. That was just becoming available. It was much faster technology than integrated circuits which had been available before. But it was much quicker. And it was, as I said, we were very early using it. In fact, there was work in Stevenage on a machine in 1966, I think, which used really some very, very early TTL circuits and test instruments. The Meckel work was actually a joint, it was really very much a collaboration between Motorola and Manchester. The people in Manchester realised there was a different way of using the Meckel circuits to the way Motorola had been previously using them. And there was a collaboration formed as a result of that, which really took Meckel forward, and which effectively gave rise, or at least one of the things that gave rise to the Motorola Meckel 10K series, which is actually still available today. So those are different circuit families. Those two circuit families were then, they then finished up by sitting on two really different technologies, top to bottom. So the TTL1 sat on these things called macros. Let's say you put a lot of circuits on one printed circuit board and interconnect them on the printed circuit board. So you're now using tracking on the board to replace that bird's nest of wiring that we saw before, or at least to replace a lot of it. The 1906A technology required the use of the connections had to look like transmission lines. And that had very small, the actual integrated circuits went to a small board, which credit size board, card size board, which you'll see there, which also had the matching resistors on it. And then all the interconnection was done through the platter. That meant it's a multi-layer platter, it's a 12-layer platter. Really quite a huge step forward in manufacturing terms from where we have been before. So big jumps in technology. Yes, I've got some quick questions tonight. Here's a macro board. You can just about see multiple integrated circuits on it. You can see there's quite a lot of interconnection on there. Still fairly simple interconnection, quite thick tracks. But now we've got these things you see here, which are actually vias, which go through and connect tracks on one side of the board to tracks on the other side. 700 series logic, the earlier logic didn't have those. So that's the TTL macros. This is the 1906A platter, that's that platter you see there. You can see the little boards. There's the plugging into the platter. And when this is a 1906, this is in as a 1906A when it was assembled. Here is a platter. These all assembled in columns. Each of these platter consumes so much power. There's a separate power supply for each and every platter in the machine. And that, of course, meant there's a lot of heat dissipated. Heat, of course, is engineering heat out of machines. One of the big things that has to be done. Huge blowers in the bottom to keep it all cool. That's another view of the same thing. So what are the machines like? We built up that technology. On the 6A and the 4A had this paging feature which we talked about earlier as an option. And partly in support of that, there was a new version of the 1900 interface called high-speed mode introduced, enabling to drive very fast drums, so you can page back and forth the drum. And that was available on those machines initially. Then on the TTL machines, there was a 4A, 2A and 3A, which were, again, just different by having different stores, but also, well, by different stores and also by a certain amount of different internal timing. And the 1901A, which now, the new departure on the 1A was that it actually had an integrated, some of the peripherals started getting integrated, so the printer was integrated with the main processor cabinet. And there was also some new disks introduced for the 1901A. So some pictures. This is a 1901A. I'm sorry about the photograph. Somebody's obviously used it as a publicity document and painted around it. It's quite interesting because it's a 1A, and the 1A is what the A series announced occurred just about to move over from ICT to ICL. It actually says ICT on it, not ICL. This is the 1A in Putney Bridge House installation. This is 3A. And those are all the pictures I managed to find of the A series on. So we then went on to the S and T series, and I've run out of time, so I won't dwell on those. Simply to say the S series was a whole series of enhancements on the A series, giving faster capability, expanding the size of the configurations. And the S series was essentially the last series which went all the way across the whole 1900 range. Then the T series, and the T series, by the time the T series came along, the top end of the 1900 range was essentially being superseded by 2900s, but we were still selling 1900s into the lower parts of the market. So the T series was necessary to bring up the competitiveness of those machines. And largely what was done there was to reduce costs by integrating things like the disk controller, using semiconductor stores, and effectively the machines were moved down the model. So what the 1903T was actually a 1904A in drag. So that's the S&T series. And then, right at the end, and actually going on much longer than before, so taking us actually almost up to the end of the 1980s, actually, was what I call a small business machine, which are really going into a different segment, still using the 1900 architecture, but packaging it, presenting it, and selling it quite differently. 2903, first machine, very much opening up a new segment, very innovative with technology, many innovations in 2903. I've talked about this, I'm sure, about mine. Don't believe what Campbell Kelly says about it, it's not right. Highly innovative machine. Used some really new things like semiconductor storage. It was one of the first machines in the world to use semiconductor storage. This really was bleeding edge, because when we actually tried to make it, it didn't work. I mean, Intel didn't do it yet, and we had terrible trouble, but we got it out, and 2903 was an extremely successful machine. And lots of other innovations on it, which we're not trying to talk about. And then ME29, which followed after 2903 into that market, which actually continued right up to the end of the 1980s. A couple of pictures, and I'll finish. Probably out of step. Yeah, I'm out of step. Let me just flip through these. These are just technology slides again. Here's 2903. Interesting shape, amongst other things. Interesting, of course, the fact that it's called a 2903, which I understand was Peter's invention. Indeed, you see it's coloured in hot tango. You see, to make everything as a 2900, really a 1900. But it was actually designed as a video set at the beginning with 8-bit internal working, so it could actually be turned into a 2900. I believe actually Galpees did in fact make it take one of the microprogram to look at 2900, although it's some such. Okay, thank you. So just in conclusion, so I believe that the 1900 range was successful over at least 2 decades, arguably 2.5 decades. That we saw in a combination of what were very innovative, very much leading edge developments, and interspersed with really quite conservative evolutionary approaches. As several other people said, I believe that the success of it, many things that contribute to the success of it, but in no small part, the success of it is due to the engineers, both hardware and software engineers, manufacturing engineers, design automation engineers, who managed to produce the complete technology and deliver the products with a much lower investment than our competitors are making. My acknowledgements to, first of all, of course, my many ICL colleagues, and especially to the people who've loaned me some of the bits and pieces which I've brought down today. To the National Archive for History and Computing in Manchester, all the photographs you saw actually came from there. And to the Manchester University Computer Science Department, because I actually went there and in fact some of the printed circuit boards actually came from there. They have a few of these machines preserved in there, and they lent me those pieces. Thank you.
Ladies and gentlemen, my pleasure to introduce you to Peter Hunt, who's going to talk about software. October 1964, I remember being in Poland around his house. 2 events occurred. Harold Wilson got elected in the white heat of technology, and I persuaded Peter Hunt to take command of the software. And from that moment, we soon prospered. Thank you very much.
Ladies and gentlemen, this is not going to be a technical talk. It's going to be just a record of events as I recall them when I was looking after software from 1900 between 1964 and 1968. George Felton is giving the talk after this, and he will be giving you a lot of technical information. In the autumn of 1964, I received a request from Arthur Humphreys to take charge of the production of software on the 1900 computer range. On reflection, I don't think the word software was used, but he was asking me to do it today, that's what it will be called. At that particular time, I was in fact head of the graphical laboratories, and I was running several interesting hardware and software projects, all of which had large penalty clauses associated with them. At that time, I had about 12 years programming experience, and I'd learned the hard way that software projects were very easy to conceive, difficult to implement, invariably late on delivery, and always exceeded budget. So I asked the equivalent to the question, what software had been promised on the 1900 series? And I was given a copy of the document. I haven't been able to find one in my archives, but the document is called document number 1024, and it was produced in order to be able to launch the 1900 series, and was used to be able to tell customers what software they would have available if they ordered the machine, and when it would be available. I've never found out who actually wrote that document. It was a phenomenal list of software on all the hardware configurations that were being announced, and also on all the different types of peripherals which you've heard about in these lectures today. Before accepting the appointment, I did in fact give it some careful consideration, and I said that I would accept it, provided a number of issues were clarified and permission obtained. First of all, I asked for permission to reissue 1024 with more appropriate delivery dates. Secondly, I asked for adequate resources to be provided in terms of competent, experienced programmers, and also in terms of computer hardware facilities under my own control, on which we would do nothing more than develop the software which we were producing. I also asked that I reported directly to Arthur Humphreys himself, so that if I had any problems, I could hopefully get them sorted out quickly. These conditions were in fact accepted, and I therefore started work. First of all, we rewrote 1024 with more realistic and appropriate information. The rewriting was not in itself a very complicated task, but the effect on the sales force, who had been selling the equipment against this promised software, was in fact rather dramatic. And I spent the first period of my time in meetings with the senior executives of the sales force and in giving lectures to the junior members of the sales force, guaranteeing to them that there will be no further slippage on these dates during the life of the project. Secondly, it was agreed that as far as people were concerned, we could recruit 100 programmers, additional programmers, immediately, which is what we set about doing. And thirdly, it was agreed that we would have under our own control in Bridge House, in Putney, under the control of what we then call programming division, hardware adequate for our software development, which was to consist of one model of each range being produced and at least one peripheral of every type that was being promised by the sales force. We organized ourselves into a number of divisions responsible for various aspects of the software we were going to produce. There was the operating system division under George Feltham. George will be talking to you later on today about the work of that division. There are a number of people here today from that division. George will be telling you who they are. We had another division which looked after the compilers, the scientific and commercial compilers under Dennis Pearson. And I know that Ted Humby's here today, who was responsible for the COBOL compilers. We had a general purpose software division for the work on plan, for housekeeping packages and so on. We had an applications programming division, which was for complete applications programs that had been promised in the document 1024 for a variety of industries and an aid to sales. And lastly, we had a services division, which was responsible for supplying the 4 production divisions with machine time, quality assurance, and also looked after the process of the issue of software. As regards the way in which we were organized, there were these 5 divisions, so there were 5 divisional managers, and every Monday morning at 9 o'clock, we all had a meeting, which included myself, to discuss what had gone on the week before regards to methodology for actually producing the software, software engineering at this stage was really non-existent. Or if it was in existence, it was in its infancy. The divisional managers themselves were allowed to decide how each of the projects that they were responsible for should be organized. There was no BS standard to which they had to work, and in particular, they themselves were responsible for monitoring progress against the promised delivery dates. In fact, PERT was one of the applications packages that we were in fact producing for running on the 1900 series. Having set up the divisions and agreed what they should do, then they got on and did it themselves, apart from reporting on every Monday morning at 9 o'clock. But one of the aspects of the work that really worried us, because none of us had had any experience of dealing with this amount of software that there was going to be being distributed to this amount of customer all over the world, one of the aspects of the work which worried us was the problem that would ensue when we started to issue this software to all of these customers and they started to find these errors or bugs in the system. The originating programmers in the various productionist divisions would have tested the software to the best of their ability, but we always knew that however well they tested it, there would still be certain bugs which would still inevitably be present. And we wanted to reduce these to a minimum just for our own reputation and convenience. We therefore set up a primitive quality assurance group. It was the task of this group to take the software packages from the production divisions once they had decided that this software was ready for release, and using only the documentation which was available to the customers, which had actually been produced by some other division in ICL. I had no responsibility for manuals or user guides. Taking just that documentation and the software packages issued by the producing divisions, used the package in the same way that the customer would use it. They inevitably found errors which were referred back to the production divisions, who corrected the errors and referred it back to quality assurance group. And this iteration process went on, and it was only when the quality assurance group signed off the package that the package was in fact released to customers. It was amazing that it was not very long in this period before many 1900s were delivered all over the world. I well remember that one of the first 1900s went to Australia, and that the salesman responsible came from Australia to see me to inform me that this particular 1900 needed a 4-track compiler on it, and that 4-track compiler had to have a specific dialect of 4-track. So this software in magnitude was being distributed, and a software distribution system had to be set up and properly organized. So it was decided that we would issue this software, the 1900 software library, on magnetic tape. And that is how the software was usually issued to customers. Eventually, of course, there became 1900s that didn't have magnetic tape, like the 1901 with cassette tape. You saw a picture of that just now. And we had to have those distributions to those customers slightly different. Fortunately, they were not the vast majority of customers. Now, customers would report errors in their software, and in those days it was usually done in writing. The telephone wasn't used all that much. And when these requests or error reports came in from the customers, they went to what we call a frontline support group, which was not in any way associated with me. It was associated with the sales force and the people that the sales force had in a special unit advising customers how to use the software. It first went to them because very often this was a mistake in the way the customer used the package in reading the manual, or just a combination of both. However, there were occasions when the frontline people operating on these customer errors really thought that it was an error on our part, in which case the software package was referred back first of all to quality assurance group, and eventually, if it was a true error, into the production divisions. And if that error turned out to be a true error, then we And this software notice would simply say, A, there is an error in this package, B, when this error will be corrected, which next release of package there would be, and C, what to do in the meanwhile in order to get around this bug which had been found in the software. Now, all of this may seem to you, listening to what I'm saying, very standard for nowadays. You really do have to remember that this is 30 years ago, and we were in fact breaking new ground. The sales force, for one, didn't like sending out notices to everybody to say that there were errors in the software. Well, as you can imagine, time went on, and it wasn't long before there were more models of the 1900 being produced, as you've seen in what we've heard today, and all of those required more software or software to be adapted to operate on those particular peripherals or machines. And what's more software was being requested by the sales force in order to deal with the competition. They were the coal-face out there trying to sell these things, and they had competition. The competition was promising other things, and we had to promise them as well. Furthermore, the existing software on the 1900 by the autumn of 1968, 4 years after we started, was over 1 million words of software that we were issuing each time a customer took a complete software system. And the number of customers was over 1,000, and they were all located in different parts of the world. Furthermore, space to hold all of the people in the division, which had been rechristened from Programming Division to be called System Development Division, the space to hold this had become a premium in Putney, and also all of the computers were occupying space in Putney Bridge South, where the sales force wanted to expand. And therefore, it was agreed that we would in fact move the whole division and all its computers out of Putney into the country, and we agreed that we would move them out to Bracknell, where we would have a special purpose built building to house all of them. It turned out, in fact, to be an aircraft hangar which was specially constructed to house all of the hardware, and a special purpose adjacent office block to house all of the staff. Certain people initially called this building Hunt's Folly, but it's consequently, I think, turned out to be one of the largest production facilities in the whole of Europe. I was very pleased in 1968 that ICT was awarded the Queen's Award to Industry for Technical Innovation in the Production of Software. Many people have asked me what the technical innovation was, to which I usually reply, well, it was simply producing some software by the date, or roughly by the date that we promised. Now, I must be quite clear and add here that the Queen's Award for Technical Innovation in the Production of Software did not only include the software for which I was responsible, but it also included the software which has been talked about by Brian Millis on the executives, and also the executive in West Cork. And it never fails to amaze me that we had here a highly technical, difficult interface between three completely separate groups of programmers, one in Stevenage, one in West Cork, one for which I was responsible in Putney. And throughout the whole time I was in charge of the software for the 1900, although I had a great many difficulties to solve, never on any occasion did I have to solve a difficulty which arose from the fact that there were these three executives all produced in geographically different locations. And it's a great tribute, I think, to Bruce Patterson and his compatibility committee that I didn't have a single request just to sort out any of the problems in that area. In 1968, ICT merged with English Electric to become ICL. I was offered the post of being in charge of all the software for the new company, which included, of course, that running on the existing English Electric computers and on the new range, which was to follow the 1900 series. I felt at the time, however, that it was time for someone else to have a go and take responsibility of a similar kind for which I'd taken 4 years earlier, and I therefore left the company to start a software house of my own with the idea that in due course I should become a millionaire. Needless to say, that didn't happen.
Ladies and gentlemen, Peter mentioned leaving us in 1968. I tried very hard to persuade him not to do that. I thought it would be a good challenge for him. He said he'd think about it. And he came back to me and he said, yes, he would stay, but there was one particular point he insisted upon being met, which was a seat on the main board. So I wished him luck on his departure. Now, it's written down to introduce George Belton. We're going to talk about George too. He is George. Thank you. Well done, George. Thank you.
Well, good afternoon, ladies and gentlemen.
Well done, George.
Pleasure to be here. I was very pleased when Virgilio asked me to speak about George operating systems. And, well, actually, the title is Operating Systems for the 1900s, but the executive, I think, has been well covered by the people who really did it. They did a very fine job. They smoothed out all the wrinkles and differences between one machine and another, and left us operating systems programmers with a marvelously homogeneous base on which to work. Our relations with the executive programmers were always very close, and we had to, of course, this was required, we had to negotiate little changes here and there, little tweaks, which were always done very harmoniously. Now, coming back to the other operating systems, which sit on top of executive, apart, that is, from the lower end of the 1900 range, where executive had to present full operating system interface to the users. On the larger machines, we had various things we called operating systems. And before I go into that, I should like to very briefly outline the antecedents of this lot, which were really on Orion, one of the forerunners. Thinking about Orion started in late 1958. And from January 59 onwards, there was very intensive work in Forensic on the basic properties of Orion and Atlas. The development of the operating system for Orion, which was called the Orion Monitor Program, that took place in parallel with the development of the hardware. So we had a lot of toing and froing there, which was very necessary. We were treading new territory. In March 59, a presentation of both machines was made to Harwell, and at this time we were still spending a lot of effort on the programming side on Pegasus and Mercury. I have a note in my diaries that on the 7th of May 59 we had a meeting to specify the floating point for Orion. Well, we designed simple but effective features in the Orion hardware. I ought to say that the hardware was actually designed by John Thompson and a friend in West Gordon, and we were designing the programmer's view of the hardware in Newman Street in London, and not writing all the software. So there was a lot of real collaboration, which was worked out very well. We decided that we should allow in the hardware the features we needed in order to provide multiple programs. We call it time sharing, but nowadays it would be called preemptive multitasking with limited multi-threading. There were certain privileged instructions which the operating system could use to allow the efficient time sharing and multi-programming and everything else. There were hardware data limit registers in Orion. The hardware, unfortunately, was not really fast enough to add the datum point to the address in the instruction. So that had to be done at input time, unfortunately. This meant programs were not relocatable. However, the data limit registers were vital because they allowed one program access only to its own bit of the store, its own bit of the memory. This meant that you could have completely independently written programs running apparently simultaneously on the machine without trampling all over each other. We were the first, I think, to do that. And still, even today, there are lots of systems that don't provide this. The PC is an obvious one, really, although they have tried their best. The 360 certainly never had it. We came from a background of programming. We recognized that there would be plenty of mistakes, plenty of bugs, and we were determined not to allow conflicts between programs. We did a similar thing on peripherals. Each program had access just to its own peripherals. This is what we call a sanitary design. Well, that's enough of that, I think. OMP provided multiple programs to run simultaneously, but it did not provide any multi-access features. This was an idea which came later out of Project Mac at MIT. In 1959, 12th of November, there was a press conference on Iran in West Gorton. On the 14th of January 1960, I gave a colloquium in Cambridge University on the architecture, and I repeated this later in universities of London, Glasgow, Newcastle, Edinburgh, Oxford, and various other things. In May 1960, I described the system to the Australian Computer Conference in Sydney. Henry Goodman, who was one of the leading people here, carried out a simulation actually running on Sirius to test whether our ideas for the time-sharing system were right and what changes to make. And I've actually got a copy he's given me of the paper he wrote following this, which you'll find in the Computer Bulletin. That's September 61. In June 62, we started shift working in West Gorton on the prototype around, developing OMP, and of course with another team developing the language Nebula. We actually ran some time-sharing programs on the prototype around in May 1963. I imagine this would be one of the world's first, and I can't really check that. At about the same time, the first customer around started acceptance tests to go to Turin's. Right, then there was a big upheaval, of course. ICT bought the forensic computer department, we all moved to Putney, and Peter Hunt was made responsible. Now, one of the first things he told me was that he had a request from Chris Wilson for an operating system on the lines of OMP for the 1906-7. He needed it to sell it. And on the 1st of January 1965, I called a meeting with Henry Goodman, who is here, and John Fotheringham and Henry Goldberg to discuss this requirement. And we really had very intensive activity from that time on, moving people about, recruiting them, running courses, reorganizing, learning about the hardware, and so on. And in parallel with this, we were still finishing off OMP Mark II. But people often ask me about the origin of the name George. Well, I didn't actually have anything to do with it, but while I was away, about May 1965, I think, I was abroad, a meeting was held in my office, because I was abroad, and there was Henry Goodman there, Jeff Strauss, Dan Oistreicher, Brian Moore, and probably some others, I don't know, but those are the four main people. And they thrashed out what would be needed to interface the operating system for the 1906-7 to executive. Which bits should go here, which bits should go there. And they started with scheme A, and then proceeded, when that obviously didn't work, to scheme B, and so on, until they got to G, and then that was satisfactory. And somebody who actually we can't find out who it was, suggested that G ought to stand for George. and I couldn't object, of course. But the reason was that it could be made to stand for general organizational environment. It would remind one of the autopilot on an aeroplane, which, as you may know, is always called George. And anyway, it'd be a bit of a laugh. On the 6th of July 65, we had a meeting on MOP. This was multiple online programming, because of course Project Mac was well known then, and several of us had heard all about it at conferences. But MOP at that time was completely separate from George. Later on, we managed to integrate them into a single routine, much to the advantage of both. And during this stage, we designed and wrote the George Input Assembler. I think this was largely the work of Jeff Strauss and Dan Oistreicher. This was ideal, it turned out, for operating systems. It included facilities for conditional assembly of blocks of code, exactly what you need to put in bits of code for instrumenting the operation so that you could work out what was happening when something went wrong. Quite invaluable. Well, in the meantime, quite soon after, in fact, towards the end of that year, word reached us from sales that they would like, please, some sort of cut-down versions of all this for the smaller 1900s. So we christened George and rechristened it George 3, and we invented George 1 and 2 to slip in underneath, hoping nobody would notice. And some of these machines had to work in remarkably small stores. We had a 32K word minimum, but some of them had no backing store apart from tape, which was really not possible. And at one stage there was a scheme called Minimop, which has been mentioned, which occupied 6K words of store and provided access to Fortran, Algol, and Gene. Right, now George 3 was perhaps the main point of interest. This was to meet Chris Wilson's original request for the 1906-1907. And this is certainly a comprehensive operating system. It covered batch work and multi-access, with the same command language for both. I think that was another world first. The 360, in fact, had two totally different command languages. And you'll find an account of this by Henry Goodman in a book, APIC Studies in Data Processing, number 9, published in 1972. The facilities included permanent file storage of a very sophisticated type, which we actually borrowed some of the ideas from Project Mac on that, and we used it on batch processing work as well as on multi-access work. This allowed for a large number of online users, and the system could also handle multiple processor configurations. The prototype George 3 system was put together in January '66 and was built up eventually for issue of the very first version to customers in April 1969. This suited the larger 1900 very well, although of course initially it was rather slow. And there were tremendous technical and practical problems to cope with in development. I mean, the hardware we got was very unreliable, and we didn't get access to a 1907 in Putney until August 1967. However, we managed to meet a date of April '69, not quite the one that was in Peter Hunt's book, I'm afraid. I'm very sorry about that, but I must plead that we weren't the only ones who underestimated the task involved in getting out a large and sophisticated operating system. I mean, almost any operating system you could mention, I'm afraid, has met the same thing, including Windows NT, on which my youngest son has been working. However, Mark V appeared. I mean, there were releases every 6 months, roughly, until Mark V in April 1971. Mark VI was in October '71, Mark VII at the end of 1972. The project then moved to Bracknell, January '73. Half the staff left, but Mark VIII was released in the middle of '74. And later Marks, in fact, proved to be very efficient, reliable, and very popular with users. People keep on coming up to me and saying how much they like them. There were minor releases for some years. The last was Mark 8.67 in 1984, George Orwell's date. Occasional corrections were issued from time to time. The last corrections were issued in 1990. The system is still in use on DME hardware, and I'm glad to be able to announce today that we believe all the recent scare stories about what's going to happen to the date at the end of 1999 will not bother George Street. However, there is a sting in the tail, because there may be problems around the end of the year 2047. Well, one thing I really would like to say, which hasn't always come across, although some of the speakers have been very good at it, but this work was under very high pressure, and there were times when we would not really, which we weren't too happy. But I must pay tribute to all the people who worked on all these systems to get them working, even if they were a little late, and to their spouses. I'm glad to say my wife is here. She put up with quite a lot. Anyway, we all survived, and really it was very exciting and stimulating time. And on the whole, I think we look back on it with pleasure. You know, you don't remember the bad bits, do you? Thank you very much.
Ladies and gentlemen, there was an item on the provisional program that Peter Ellis is going to talk about ICT in the 1900s, but we've really been doing this, and Peter and I thought that perhaps it would be inappropriate to pick that theme up. I think what has been put over today is the tremendous efforts that were made by everyone enthusiastically employed and engaged in a pioneering effort. I think before the 1900 release, ICT stood for in constant trouble. After the 1900 release, it stood for in comparative triumph. And this was entirely due to all the people and all the collective efforts that were made by everybody. And it was a credit to, I think, the nation that we were able to achieve this. Everybody that's involved in it can be proud of the efforts they made. I just regret one thing, Peter, all this is, I wonder what would have been the position if only in 1959 Boylston and Sebastian could have agreed to solely the vision then. So many things we did because they didn't, we would have avoided. And it's tremendous to think that as they didn't, we did pretty well to fight our way out of the problems 4 or 5 years later. But ICT and the 1900 is really a very important sense of Julie Peter Hall, who did not give up with the two boys to persuade them the right course. And I've always been grateful to Peter for being associated with him in that regard. Now we set aside some time for questions, and I'd be happy to organise questions and answers if anyone of you wish to raise them. But I would suggest, it's been a long day, that we seek to close the meeting at 4:30. I hope that will be agreeable to you. Are there questions? And if so, I'd like to know what they are, and I'll try and allocate someone who is best able to answer them.
I think Arthur's trying to encourage me to tell a little story about 1959, which many of you will know. I'm just looking around to see how many ladies there are here, and I hope they'll excuse what I have to say. I've been working with Arthur for some time before 1959 to try and see a way forward for ICT and Ferranti together. And we were purchasing things from ICT, like printers and electronic devices and a few card readers and things like that. So we knew a bit about ICT and their products. And I eventually managed to persuade Sebastian Ferranti to come down to a meeting which Arthur set up for us to Park Lane and to discuss this project that Arthur and I were on of taking over the Friend activity. And Sebastian, being a young man, very young then, he refused to be briefed about all this, of course, until we were in the aeroplane on the way down. And I gave him all the reasons, which I won't enumerate, why this would be a good thing, and why it would be good for all the staff in Ferranti for this to happen. And I told him of all the strengths we had and how these would complement ICT. And I said, because ICT haven't got the technical strengths. I said, take the equipment they sell us. It's a load of bloody crap, the stuff they use. And he took all his yes. And we got to Park Lane, and I mainly emphasised the positive things. This was just an aside, almost a joke. And when we sat round the table, and there was Cecil Mead and all sorts of all the top brass on the board of ICT. And we were around a circular table, which I mentioned was in John Bull's office. He was managing director there. It was a circular table with a central pillar that wobbled. And when you put your hand like that, you see. And we were sitting around, and there's a lot of pleasantries, and it was all very formal and very nice. And then somebody said, well, let's get down to discussing this, you see. And Sebastian said, well, this is all very well, but the trouble is, your equipment's fucking useless. And he banged me on the shoulder and said, tell them why, Peter. That actually happened, and that was the end of the meeting. And we never got together. It took 4 years after that, and Arthur and I sorted it out.
Now it's a really close dish. Anyway, Cecil Weir was a nice gentleman. The others, Cecil Mead was a very nice gentleman. We had one or two other people that their contribution was marginal. If we're talking anecdotes, I always remember the first board meeting I attended at ICT, Mr. Organ at Echo had put up a paper that we should close down the Powers research establishment at Whiteleaf and take the people and put them at Stevenage. And he made the point that the people we really wanted probably wouldn't want to move, and those we didn't want would move. So there's quite a problem. Anyway, so he would play for that. He sought the views and members of the board, and then he made his own contribution, which was, well, I suppose we'd better close it down. But it'll be a pity, because Molly and I were missing it on the way to Trineborn. Questions?
The 1900 environment, and particularly George III, became very popular when it was possible to run it on 2900 hardware using the direct machine environment originally. I wonder if any of the speakers believe, given hindsight now, whether we would have been better to have launched the 2900 series initially as a 1900 environment, whilst we were building a much more sophisticated 2900 operating system.
Do you have a view, Michael?
Yes, but I'm not sure that I ought to express it. I think that that was politically impossible because the new range was to be the consummation of both System 4 and 1900. If you launched it at 1900, you wouldn't, I think, have met Colonel Maxwell's criterion, which he had said very largely in public, that current users from both ranges would be able to carry their work forward without undue difficulty.
Well, that was the political stuff from which we went. I went down to see him in 1963, I think it was 63, and he said, no, this was in 73. And he said, I wonder whether you would agree to put up a small team with some people from English Electric to see whether it would be possible in some way with ample government money to come out with a new range which would enable existing customers to transfer their work without undue difficulty. And so I said, yes, I think so. Be prepared to do it. Well, I'm pleased to see that. He said, I'm pleased to hear that because George Nelson has already agreed that he would. So we were lucky enough to ask Peter Ellis to do it with George Felton. And he went off with two distinguished colleagues from ICL, and they came up with a paper which indeed said, yes, it technically was possible. But it would be impossible to do it if we were in competition. So that led to the merger of into ICL of ICL. I wonder what would have happened if they said it wasn't possible. Because I tell you, as far as I was concerned, having my 10 cents worth, it was with the greatest reluctance that I wanted to be involved with East Electric, because I thought, having all the trauma of the 1900s, to then have to go and persuade customers that System 4 was very good as well, but to be that whatever you said, you were going to tarnish the other one. And indeed, I remember, if I can tell this story, as David Cameron's written a book, and he didn't mention this, soon after the merger, he came to me and he said, we've got a problem with ever-ready batteries. That they signed a letter of intent for a System 450, but it looks as though they're not going to implement it. And so I wonder whether you come with me and we can persuade him that it would be very wise for him to order the 450. So I said, yes, I'll come with you, David. So we go and see this back chap, and he said, well, I don't know. He said, it doesn't sound very convincing to me. He said, you now tell me I should order a 450, Mr. Humphreys, but I've got many letters in my file from your Mr. Dennis Rich that tells me that if I do that, it'll be the greatest possible service to my company. Well, I said, Joe, this all happened in the earlier of the marketplace. So then he added, he said, as I said, you ICT fellows have hogged the whole show. He said, you got most of the posters in, and it's you ICT. So I said, well, is there anything wrong with that? Not necessarily, he said, but if you've got any sense, you're scrub System 4.
I would like to volunteer an answer to the question which Derek Village posed, that we should start it off with the 2900 range being obeying the right microcode to make it look exactly like 1900, so we run all that software and continue it. I think this would have been quite feasible, and we could, I'm sure, have another alternative microcode to get it to obey the System 4 programs. There would be no problem in that. But how you'd ever get them really to merge, I don't know. They'd be running one or the other. You couldn't really chop and change it all easy, I think.
I have not really, it's a side question, or not only for operating, but for Derek Eldridge. As George Felton has made quite clear, one of the essential innovations in Orion was the inversion of the data and limit mechanism, which ensured that a fault in one program couldn't sabotage any of the other programs or indeed the operating system, which was a pretty good idea. It was taken on by the FP6000, who said when they described it, they said that the FP6000 was a cross between Pegasus and Orion. And that particular technique is inherited from Orion, and of course it got all the way into 1900. I got the impression, I'd like to ask Derek Eldridge, in fact, it might be that ICT knew how to make a sanitary operating system with protected programs before IBM did. Is that or is it not?
Yes, I mean, the answer is yes. Although, of course, it was an objective within the IBM system to do just that, which they achieved much later. But I think the answer to your question was that in choosing the FP6000 as a basis for a range, which we had to do rather quickly, there were a number of contenders. None of them had all the desirable characteristics, but certainly things like data and limit and multi-programming were high on the list of desirables, which put that one near the top of the list. And we then, having narrowed it down, looked at the deficiencies, saw which of these deficiencies could be overcome most quickly and readily. Cheaply, I don't think the word cheaply is the appropriate after what it said, but conveniently as possible, and the FP6000 came out at the top. And obviously it does owe, I mean, with its history of the engineers who came from Ferranti Packard wasn't specifically brought out, but they actually came to help with the development of Orion originally, and surreptitiously, in their spare time, shall we say, at Toledo, spent the time saying, we're helping, but this is the machine we would like.
Well, I'd like to add a little to that, if I may. We had an Orion description, which was sent to a standard distribution list all around the company, and it included 2 of the Ferranti Packard people. So they got everything that we were doing, they knew exactly what we were doing. They'd also knew Pegasus very well, so the cross between Pegasus and Orion would be a fair description, I think. Yes. As a matter of aside, I read that there's a book on how to write secure programs for the IBM 360 series. It was published some time ago, and there's a little warning at the bottom of the first page that it's actually impossible to be totally secure because of a lack of this facility. Very well.
Thank you very much. Mr. Zambas, you seem to confirm between you that perhaps there was a time when ICT did have, in its 1900, a decisive technical advantage on the software side, which was ultimately inherited from Orion.
Yeah, I think the kind of on that as well. One must at these occasions not be too negative, but IBM's strength was hardware, and always was. In the software area, their approach was put 1,000 people on it and you will achieve the objective. And we all know that 1,000 people actually achieve less than 100 when it comes to developing software. And they did not have a history of good software development, and really they were working to a marketing specification which was really inadequate. Whereas within Ferranti, certainly, and working in conjunction with Manchester University, I think, which one should not overlook, ideas of this sort were being thrown around, tried out in so many machines it wasn't true, that they were well known.
Just one point on that, David. I don't know whether you were here at the IBM equivalent seminar for this, but and how many people here were there, but they very carefully, I thought, addressed this very point. And they addressed it by saying, when we examined our customer base and how to ensure our continuing ongoing revenue, these are the things we needed to have. And these, if I'm showing multi-programming things, we did not need and we will not have deliberately. When we need those, we'll put them in later on. But the essential thing was to preserve our customer base, and the designs that they implemented did just that. That was our argument.
IBM certainly had a storage protection facility which worked on lost memory, but it was very crude and it wasn't really supported by the software.
It was circumventable.
Could I make a point as an IBM? The most important thing for us in the 360 was a disk-based operating system. And disk access, index sequential files, were the things that we thought were important. And I think they were right in that judgment. Because ICL was losing disk-based systems right until the 80s, as far as I can remember. Where there was an application that could run on disks, on the whole, we won. That's my view.
Ladies and gentlemen, may I introduce Mr. Kawata to you from Japan, because he's come over especially to come to this seminar, because he's engaged in writing some history of the significance in Japanese computer activities, and now with particular reference to ICL and Fujitsu. So he's been to see one or two of us here and asking questions about the past, and I thought that he would be interested to have a little bit more in this. I hope he has, and now he has a question. Mr. Kawata from Japan.
Thank you very much. A rating question. When Mr. Elrich spoke about FB6000 this morning, that was designed originally for seat reservation. I thought much funny because the reason why the ICT and English Electric couldn't unify the product so long, having trouble inside, was the reason why that was the because ICL didn't have online real-time operation function, but only English Electric had. Hearing this story, I suppose that if ICL is the key word, an American market, it could employ some person very good in online real-time operation. But you didn't do that according to British way of doing business. But today I have an impression that the FP6000 already had the real-time operation. Isn't that right?
George?
Yeah, I think, Mr. Carmichael, you're right there. My recollection of well, I visited the Canadians several times in Toronto. Very nice bunch of people, very talented. And they did have a seat reservation system for what was called Trans-Canada Airlines in those days, which had twin computers called Gemini. So if one broke down, you'd carry on with the other. They were also involved in systems for traffic control, chiefly in the city of Toronto, where they put in a large system. And they were steeped in this real-time business. They used small machines for all sorts of jobs, many of them real-time. And I believe that the FP6000 would be very suitable for real-time use. I personally have no experience of real-time operations, but I can't see why it shouldn't really work very well.
Thank you, George. Yes?
There's been no mention of George IV,
which is the page version, of course. And I would like to know if it was ever used, given that I left West Gordon after designing a pager unit for 4A, and I never knew whether anybody used it.
Yes, they did. Leeds University, RAF, Farnborough.
Is that on 6As or 4As?
Yeah.
Oh, 4As. 6As.
Only on 4As. I don't know.
No, RAF Farnborough had.
Farnborough had an advanced machine, yes. George IV was one of the, it had paging facilities built into it, and these were assembled when required by this conditional assembly program facility in Gin. So it was really all one piece of source code. You just pulled out the bits you wanted.
It's also the case that special compilers were ready to consolidate and take advantage of the environment.
Good.
Howell had a 6A, I think. Did one have a mentioned?
Yes, they would be.
I seem to remember having read in the Leeds University prospectus about 1975 that they had a 6S George IV.
That's 6 George IV.
So maybe they made a mistake on the 4A. That's all that.
I'd like to raise the question of manuals, because as a user, particularly we had 5F and 5E for 10 years at University of Surrey, and it came as a particular bucket of cold water after coming from what I think was one of the best manuals that I've ever read, which was George Felton's Programmer's Manual for Pegasus. Had the shelf full of manuals for the 1900, and we found that in fact you did have to have the shelf full of manuals, because there had obviously been some policy decision that nothing should ever appear twice in a set of manuals, so that you couldn't make any inquiry with any confidence unless you had the entire set. And I gather from your remarks, perhaps you say a little more about this, but they were not written by the people who were producing the software. And this was certainly the impression that one got, that they were in some very arid, as if they'd been written
by AT&T. Someone can say a little more about that. This matter was used as
I'm sorry, I can't counsel there. All I know is that the manuals, and there were also some things what I thought user guides, in other words, the best way to use the package, or most efficient way to use the package. They were written by a series of technical authors who had access to the package itself, and also, of course, to information coming from the originating program. But the originating programs did not write them. In fact, I think that is the correct method. Whether the manuals that the technical authors produced are good or bad, I can't say. But if you had the originating programmers producing the manuals, they'd be 10 times worse. Because they know too much about the thing. They can't explain it in simple language. They'll omit half the detail. It's a disaster. They will be a disaster.
Well,
a different disaster. A different disaster.
Yes?
Yes, one thing to mention in connection with Midlock is Gene programming language. Now, I remember using Gene on Jaws 3. What was the origin of Gene?
it came from Joss and John Mack.
Jaws extended and adapted for 1900.
Exactly, that's right.
Thank you.
Sorry, I'm Richard Dean, who worked on sales support of the early days of the 1900, and there are two comments I make about 1900. The first one is that it's the only time I've ever seen customers applaud at a launch. Actually, some of them stand up and cheer. This was the very first time that ICT had ever done a professional launch, and customers were so relieved. It was almost untrue. The other thing, which was perhaps slightly connected, it was the first time we ever tried to train our salesmen on a new product. And all often very reluctant salesmen went for a week at, it probably wasn't a week, 3 days, I think was the most they could be persuaded at Cookham, where they were taught about things, including the non-existent exchangeable disk store, which was a vital armory in the sales armory there, because as our friend from IBM pointed out, we were being beaten hands down all the way around for not having the exchangeable disk store. And the fact that we promised we would have one sometime, although we wouldn't have it tomorrow, was absolutely important.
Well, excuse me, well, we did have an exchangeable disk store, but I believe it was not available from the outset.
That was the point. They were taught that they had to explain we had an exchangeable disk store. You just wouldn't get it with your first delivery if you insisted on early delivery. You would get it as a second delivery.
To technology's point about EME, the 2900 was much vaunted as an architecture specially designed with high-level language compilers and operating systems in view. But I remember hearing that they've done some tests of the first EME, and the machine ran faster as a 1900, I am not making a load, and the DME that was issued initially was very heavily slow. It's almost the opposite, so point.
I believe that was actually true. I remember, again, the ladies present won't mind me saying it, but there was an article on that very subject on the front page of Computer Weekly at the time, I think it was, where they said the problem for salesmen trying to sell new range, the 2900 series, was that customers were getting too good performance out of the 1900 emulation. They were getting the performance of DME was so much better than the 1900 machines they'd been using. And as one, I think the phrase was, one wag in IC, was it ICL then? One wag in ICL put it, it was rather like masturbation. If you kept doing it, you began to confuse it with the real thing. They were saying people should move to new range, the real thing, but the difficulty was prizing them away from what was a too good DME.
Yes, Brian Proctor mentioned
about semiconductor memory, do you actually have a date when that was introduced?
As far as I'm aware, the first semiconductor memory was introduced on 2903, which was at Hanover Fair in March, April 73, and was first shipped, I think, in probably November 73.
Yes, because...
and then just quite shortly thereafter, the semiconductor memories were introduced on the T-series machines, I think, on the 1T and the 2T, which are the Stevenage machines, and also on the 3T, which actually has had a 4A.
Just in relation to your comment about probably being the first semiconductor memory, I used to work for digital equipment for many years. The PDP-1145, which came out in 1973, offered partial semiconductor memory as an option.
Right.
It again used to be at Intel 11.
It was all in MS3, so that was all that's available.
And they also offered a high-speed semiconductor memory option using the 74S200 256-bit chips.
Right.
Which was very limited in size and very power hungry, very expensive.
Actually, on the 29, I mentioned, I didn't go into any details, but on 2903 I mentioned that there were, at the time that, certainly at the time the production started, that actually there were severe difficulties because Intel were actually unable to make the 1103 and make it reliable. And in fact, one of the things that was done on 2903 in order to circumvent those difficulties and actually get the machines moving was to introduce a thing which we call the floor store, which actually enabled dynamic replacement of bits of the memory that stopped working. And that floor store actually used that faster semiconductor part. It was, as you said, very expensive. It could only be used in small quantities.
Well, did the 4S ever get semiconductor memory? Because I remember some going out 4X.
I thought 4S only had the locking stores. I'm not certain. It's possible the semiconductor memories went back into 4S, but I'm not sure.
Some of them were due to be retrofitted, I remember, from some university content.
Right, it's possible. It was a little bit murky in those days, which stores finished up which machines.
In Brian's list of interesting photographs, there was one omission. I remember from the brochures that came out at the launch of the 1900, one fabulous device, the size of a double wardrobe, with probably 8-inch CRT or top left-hand corner, which is called visual display unit.
Oh, yes.
Did this ever happen?
I'm not sure it ever happened, but you're right. I did actually see one of those photographs. Yes, I should have done one of those as well. I can sign that as well.
I've just remembered.
Yes, I think that's sorry.
Remembered another interesting innovation of the launch, apropos what Richard Dean was saying, which is that the operators on the consoles were actually all engineers. Brian and I did in 1902, and Charlie and somebody else did in 1904. And the reason was, Mike said, it was all done in quick time, and there really was no chance to train the staff up. So they said, well, who's got the best chance of recovering if there's any disaster? They said, well, the blokes who designed. So Brian and I done the logic 1902 trip. So they said, we can make them look like salespersons. So that's how smart, which is like that. And I suppose that was quite a tribute to us in a way, because I mean, for engineers to be allowed into what's a very heavy or sales-oriented arena was quite some achievement. But we did it in shifts between us. And Charlie, anybody know who did the other shift? Was it you, Chris? Charlie and somebody else did in 1904. So that was another innovative bit. It was the only way we could possibly have got it done in the time.
Can I add a bit more about visual display units? Because there were two development projects. There was a general purpose visual display unit, which was the big one. It wasn't quite as high as wardrobes, but it was the big one. And I think it was destined for, would you believe it, something like a fingerprint recognition system. Now, we've heard this story of fingerprint recognition, I think reinvented many, many times over the years. But I remember working on some of the electronic design of the GTVDU. But there was also a multi-access system, which was going to have a lot of small VDUs. And I worked on two versions of that in 65 and 66. There was going to be an electrostatic tube version to start with, and then it went magnetic. But it all vanished into the woodwork somewhere. I got drafted on the 4A and never saw it again. The GTVDU hung around for a while, but eventually disappeared. Incidentally, I've left on the table over there the simulation listing and some sample output from a 4A microphone, because we simulated the whole he's developed an algo-like language called Symbol, which was then used to simulate the whole of the microprogram. And as being said in time-honored fashion, we actually used as our base the paper tape, which contained all the CPU tests. And if we could run that paper tape correctly, which we did at about 50 simulated instructions a second on the Manchester Atlas, then bingo, we had a machine which would go. We didn't simulate a floating point. That was really beyond us at the time, but all the basic machine tests. And so we ran the 1900 basic machine test tape into the Manchester Atlas, and you'll see one or two of the results there. I have some more material, but that is going to stay here at the Science Museum. I promised to only sell some while ago, but I haven't handed it over. But I do have photocopies. If anybody wants them, I could reproduce them. I know Phil Brady has got a set of logic diagrams. I hope somebody will get it for a running again somewhere.
Can I just add about there wasn't any VDU bought from COSA, and it was a monoscope it was called.
Tell me more about that.
Come on. Well, it had an extra CRT in it, which was no more than a set of characters in wire, which it scanned the character and took a raster scan of that character and then corrected it back onto the screen. Now, I was involved in a few of those being delivered, but I didn't quite know what they were used for. What happened actually?
We had a mock system that Steve Ridge using, trying to tell me the type number recently. Are those little costs we used, remember? Right?
Well, one of those came into the lab at West Gordon because we hadn't used plastic encapsulated transistors. No, they were not reliable. They wasn't properly hermetically sealed. And somebody, whose name unfortunately I forget, said to me, do you think we can get it through quality assurance people? And I said, yes, but you'll have a lot of trouble. And he did go into the product line as a bought-in product, and it was not a particularly reliable machine, but it did good duty. And English Electric used it on the System 4s, which is where I've seen them use it as console terminals on the System 4s.
I think there are a few people here who will remember an online rake bush Murphy to a 1903A that was used primarily for the development of new range on the sequences. And I think Keith Crook may have written the first ever Space Invaders program.
How many 1900s of all times were produced?
I'm sorry, what did you say?
How many? Quantity?
How many months?
1900s.
How many sold? Yeah. All right. So now you have here? 3,000?
There were over 2,000.
2,529.
So we're over 2 billion. Was it? In total. All right, dig out the figure somewhere.
Perhaps in the report that we brought back from first visit to Brain Packer, we thought the machine would be quite successful with Ferranti. We sold 20 in the first 2 years, a total of 50.
I think on that point, I actually discovered a document in the archive that said that I think it was after 2 years of sales, that at that point, the number of sales of 1900s by then exceeded the total sales of Ferranti, ICT, EMI, and the other companies that the original have gone to.
I think another point is that the book is still open, because just about 6 weeks ago, ICL announced the sale of 2 copies of an application called the Matchfix Core System, which is a 24-bit application. So the new sales.
If I may, just for a moment. There is a number of copies here. They're not afraid to proposal that was produced by APS Systems in Manchester, which has got a little bit of history around it. Regrettably, in this assembly, I have to admit that as far as I can tell, the picture which claims to be a 1900 is actually not a 1900 at all. So, other than that, it does have some other interesting information in it. So, if you would like to copy, there are a modest number of copies here.
Yes.
I have a question concerning the University of Manchester Regional Computer Centre. I was a student in the mid-1970s, and there was 1906A there, which was connected to a CDC 7600. I believe this was a very successful venture. I wondered if anybody knew anything about the background and how that came about.
It was a non-standard version of George 3 running on it with extra features designed for that front-ending role.
Yeah.
There was some special software written so that you could use the CDC as a background number cruncher, and George as the way of doing the job description and compilations and all the other stuff.
But what was the initiative behind that? Was it something that the university promoted?
No, I think there was a joint company being proposed of multinational data or something like that between CDC and ICL. And this was a cooperative venture to try and get the two companies together. And I was actually the engineer who was sent over to Minneapolis to actually get there's a joint coupler between the two systems, and a small team of hardware and software people were sent over to get it working. And I think it was just a trial venture to see if the two companies could work together. There was a 7600 actually installed in West Gorton, and then it was moved to...
Yes.
Roy Newbury, might be of interest to you all that while on a visit to ICL in 1985-86, I took the opportunity to look around the Science Museum in Ottawa. And there on display, very proudly, is Canada's first and only computer labelled the FP6000. Alongside it, if you believe, there is in actual fact a 1925 punch in 1900 range colours, still on its dolly with its red trolley and the four wheels. I verified that as of 1985-86. How the two came together is another story.
I wonder in the count of 2,000 or 2,500, the following was included. Was it not the case that the Poles and possibly another East European nation produced a copy of 1900? Yeah. I don't know how many there produced, but
There was a production I had in India.
Yeah,
in India, yes.
Well, ladies and gentlemen, I think the time is 4:30 and it's time to close the meeting. I'd like, if I may, to say a good thank you to all those of my colleagues who made the presentation to you. I'd like to thank you as the audience for coming and for apparently being interested and attentive. I hope you found it interesting. We believe in a company that was a unique event in British computer history, and we're proud to be associated with it. But thank you very much indeed for coming, and I'd like to thank all those who are responsible for the organisation, who did every big part, and the Science Museum to provide the facilities. Thank you very much indeed.
On behalf of the Computer Conservation Society, I would like to thank you, Arthur, and your team. I must say, listening to it, I realised just how courageous it was, how far-sighted the early work really was when you consider the period of time and the changes through which that basic architecture survived. And if only we'd had the resources on the financial side where we might have got with it. Anyway, thank you very much, and can I encourage you to join the Computer Conservation Society, which really won't cost you anything.
The difference
It is,